Howdy NRF. I'm just going to do a quick review of some of the stuff we covered last time, and then this is going to be a shorter video. It mostly is stuff that I mentioned a little bit in the last one, and really is the grade 9 material on using exponent laws. However, now that we have some fractional and negative exponents, we can mix it together with that. Mostly going to be mixing it together with negative exponents because we are going to, at least for the time being, ignore doing fractions that don't have a numerator of 1. So that kind of limits the ability to mess around with those too much. But if you want to take a look at those, they're definitely, there's some work available to you in sections previous to this one. So let's go ahead and do a quick review. A lot of times these questions will ask us to write things as having a positive exponent. So what the negative does in the exponent position of any of these statements is it tells you to do the reciprocal of whatever's written there. In this case, we have 3 to the minus 2 power. What we can do as a first step is rewrite the 3 and then use a positive 2 power instead of a negative 2 power. So the way that reciprocals work is it takes something that's in a fraction form and it flips it so that the numerator becomes the denominator and the denominator the numerator. In this particular question, we have a 3 as the base there. 3 is the same thing as 3 divided by 1 if I wanted to write it in more of a fraction form. So in this case, if I take it and I flip it first, it becomes 1 divided by 3. So 1 divided by 3 to the power of 2 is the same thing as 3 to the negative 2 power. So we can leave it there. That is the exact same expression written with a positive exponent now that we have a positive 2 there. This isn't very common to be asked to write it with a negative exponent, but I'm going to do the same thing, just in reverse. So the way that this one works is we have a fraction to begin with, and we're told that there is a power of positive 3 on the outside. If we wanted to write that as a negative 3 power instead of a positive 3 power, then again, the way that the positive and the negative exponents are related is that they are the reciprocal of each other. So in this case, instead of being 2 divided by 7, we'll flip the numerator and denominator, and it will be 7 divided by 2. So I can write that same thing by using a negative exponent instead. Next up, this one, I'm just going to, for a little bit of practice, ask that we write this particular value with using no exponents at all. So that actually is going to use a little bit of one of the exponent laws that I probably need to brush up on in just a moment. It is from grade 9, but just a moment. So we're going to start out with 3 divided by 5, and then to the power negative 2. So the way that this works is that the negative is going to flip us. So we're going to get 5 divided by 3 to the power of 2. That's what our negative in the exponent will do, give us the reciprocal. However, at this point, we need to know how to interpret how the square on the outside of this bracket affects the fraction. Now, I could, I guess, do this avoiding any sort of exponent laws at all. Maybe that's what I'll do for this time. So something squared is the same thing as taking that something and multiplying it by itself. So we're going to take 5 over 3 times 5 over 3. And because we understand how that works, because when we multiply together fractions, we multiply across the numerator, then across the denominator, we're going to get, in this case, 5 times 5 is 25, as well as 3 times 3 is 9. So the way that I've written this in the end, I have 25 and 9, neither of which is currently expressed using any exponents at all. So I've done what the question asked me to do, which is write this particular 3 over 5 to the negative 2 power by using no exponents. All right, so I'll come back to talking about our exponent laws in just a second. So this one is asking us to write it as a radical. We won't be using that a whole lot right now, but that's okay. It's worth taking just a little bit of a look at as a reminder. So 15 to the 1/3 power is equal to, we're going to write it as a radical. The 15, that's the base on the exponent form, goes right inside. And this 1/3 power is actually what determines the index in this case. Actually, if I want to be a little more specific, because it's the written in fraction form, it's actually the denominator of the fraction that determines the index of the radical that we're taking a look at in this case. So this is 15 to the 1/3 power. That means we have 15 cube rooted, so the index of 3, the same as the denominator of 3 for the fraction. All right, so we're going to now get into the idea of applying exponent laws. So our exponent laws are things like this. If I have a, actually let me do x to the power of a times x to the power of b. They have the same base, so we add the exponents. And again, I'd mentioned some of these in the last video, but just to recap them, if I have x to the power of a divided by x to the power of b, that would give us x to the power of a minus b. So we can subtract the exponents instead of dividing. It's really important to note that in both these examples, it's not a fluke. The bases need to be the same as each other. If they're not, then there's no simplification that can be done. At least not without rewriting it as the same base, which can be simple in some cases, but generally is not. All right, now, if I take x to the power of a and say that that is all to the power of b, then in this particular example, we can take those two and multiply them together. So it will be x to the power of a times b. If I have x and y to the power of a, then the a actually affects both the x and the y, and we can write that instead as x to the a, y to the a. If we have a fraction of x over y, and then we have that to the power of a, then that's equal to x to the a divided by y to the a. So this group of things together is basically going to make up what we're going to call, I'm looking for the textbook actually, it's going to make up what we call the exponent laws. And I'm just going to make sure that I didn't leave any of the ones that the textbook decides to talk about out. Let's see here. Nope, it's those 5. So we are good. The only thing in the last one is it doesn't technically work if the denominator is a 0, because dividing by 0 isn't going to give you any value. But other than that, we're good. So I could put in here y does not equal to 0. All right. Now, once we have said that those are the same exponent laws that we used in grade 9, we can go forward and just use some of these while also incorporating some of the negative exponents that we were just taking a look at last time. So we have 2 to the power of 2 times 2 to the power of negative 4. The bases are the same, therefore I can add the exponents. 2 and negative 4 added together is negative 2. If I was required, which the instructions this time do say express as a single positive power, I have to go a little bit further and say that that's the same thing as 2 over 1, which means I can write the reciprocal as being 1 over 2, now to the positive 2 power. All right, I have that lovely habit of starting way over to the right. All right, so next up is going to be 5 to the 3rd power, all to the power of negative 4. This is the exponent law where you have an exponent with a bracket raised to another exponent. The way that we deal with that is you multiply those two exponents together. So we're going to multiply 3 and negative 4 together, and it's going to give us 5 to the negative 12. Again, that is not written using a single positive power, so it's 5 over 1 flips to become 1 over 5, now to the power of positive 12. And the last one on here is going to be 3 to the power of negative 3 divided by 3 to the power of 5. And so, again, this is a quotient or division, so we're going to subtract the exponents. So that would be 3 to the power of negative 8. Negative 3, subtract another positive 5, gives us negative 8. And then that's going to be 1/3 to the power of positive 8. For these three examples, I just had them all become negatives, so we did have to do the little flip at the end, just as a reminder. But it wouldn't have to be that way. If we had done the operation and it ended up giving us a positive exponent to begin with, we would just be done there, and we wouldn't need to do anything else with that. All right, so this also works with variables. So when I was doing the initial setup of these rules, I did use letters for the base. In this case, that's what's going on. So we have x squared, x to the 5, as a division, all to the power of negative 3. So I'm going to follow my order of operations, and I'm going to do what's inside the bracket first, although it actually doesn't matter because it could do the exponent laws here all at the same time. But that's the way that I'm going to treat this problem. So I'm going to do x to the power 2 divided by x to the power 5. That is a subtraction of the exponents because it's a division of the things that have the same base. So x as your base, x is your base, it's in a division, subtract the exponents, 2 minus 5 gives us negative 3. Still have a negative 3 kicking around on the outside of that expression. So next up, I have something that is something that has an exponent raised to another exponent. That is a multiplication of those two exponents, and so in the end we'll have negative 3 times negative 3. A negative times a negative gives us a positive, and 3 times 3 is 9. So we would get x to the power of 9 is the simplification of that one. So just as a last example, have something that's a little busier in terms of the stuff that we're expected to do there. So we have x to the 3, y to the minus 2 times, in a bracket, x to the minus 2, y to the 3, all to the power of negative 2, and then in one big bracket, all to the power of negative 1. So again, I'm going to actually follow order of operations as I go through this and see how this will treat us. So I'm going to copy it down first so I have it to look at, and then we'll go from there. So my inner bracket is this right here. And so inside of that inner bracket, I have two bases that aren't the same. So I can't put them together. So I'm kind of done that. It is the way that it is. But I do have, on the outside of that bracket, a minus 2 exponent. And so that minus 2 exponent can be brought into both of my pieces, both of the factors that are inside of that bracket. So I'm going to leave everything else alone, and I'm going to choose to do just that one part. So when you have something that's raised to a power in a bracket, it goes on all the factors inside, and it's a multiplication of those exponents. So I get x to the power of 4 and y to the power of negative 6. Still have my outer bracket with the minus 1 power on the very outside. So now, as we said before, I can't really do anything with these brackets, and to be honest, this bracket and here, they're not doing anything because there's nothing left to do inside of that bracket. So they could be not written, and that would be fine. So next up, I do have a multiplication of all of this stuff happening inside of my outer bracket. So I have x to the 3, y to the minus 2, x to the 4, y to the minus 6. So I can put my parts that have the same base together. So I have an x to the 3 and an x to the 4. I also, have a y to the minus 2 as well as a y to the minus 6. So when I multiply together my two bases that are both x, I add the exponents and get 3 plus 4 is 7. And then I also have y to the minus 2 and y to the minus 6. I'm going to multiply those together, and that's going to give me y to the minus 8 because we add those exponents. Also going to have a minus 1. written on the outside of this. So as a last thing, that -1 is going to be multiplying in, and it will be x to the -7, y to the +8. Now, depending on how this asks us to simplify it, this would be fine as a final answer. I only have one position that I have a base of x and one position that I have a base of y. That's pretty nicely simplified. If it did say to do it without having any negative exponents, then we could take the part that's just an x, and it is like an x over 1 to the power of -7. That's the same thing as x to the -7. So I can flip that to being 1 over x to the power of 7, and then y to the power of 8. And the 7, just like it can in the multiplication case that we did up above, it can be brought in to both the numerator and the denominator as a power of 7. So 1 to the power of 7 is nice and simple because it's just 1 times itself 7 times. It still gives us a 1 in the end. And then we'd have x to the 7 down in the denominator because x multiplied by itself 7 times is x to the 7. All multiplied still by y to the 8, which means that our final answer without using any negatives would be y to the 8 divided by x to the 7. This type of example definitely takes a little bit more getting used to most of the time because there's going to be a number of steps involved. Make sure that you're comfortable with the actual individual rules first, your exponent laws. And once you're good with those, if you're focusing specifically on how to do this with negative and positive exponents, there's going to be a lot of integer addition, subtraction, multiplication. So you have to be comfortable with how to deal with positives and negatives at the same time. And that might take some review too. But once you put that all together, then doing some of the practice problems I'll list under this video will be helpful, and hopefully will get you going to be able to deal with these if you take courses that see them later on in grade 11 and 12. Take care.